And hello everyone, welcome back to another C++ tutorial. Today we'll be looking at references. So passing values as references and so on and so forth. So let's say we have an integer, we can just call it a and make it equal to any value whatsoever. Now if we were to see out a, then I'm pretty sure by now we all know what we are going to get. So if we run here, we get 12 as expected. Now let's create another variable, int b, make b equal to a. Now if we print out b, we know that we are going to get b. So we have 12 and 12. Now when we go here and we say b is equal to 24, for example, and we see out b again, what do you think we're going to get? Well, by now I think we all know we're going to get 12 and then 24, because b is actually its own variable. So when we look at a here and we do this, that means that b just gets the value inside of a, but a itself stays the same and b will change when we change b. So if we were to copy and paste this, and we would change this from b to a and just make, or just print out a, we don't even need to change a, we can just print out a. Then you'll notice a is still 12, even after we changed b, because there are two different variables, two different locations in the memory. However, we can create a reference to a variable, like int b, and we just do this, and we are saying that b is a reference. It is a variable, but it's referencing something else. So now when we run this, we get 12, 12, 24, 24, because a has been referenced by b. When we reference something, so when we say ampersand and then our variable is equal to whatever is here, so this should be a variable, then we are saying b becomes a. b is basically the same as a but a different variable name. They have the same location in memory. So even if I were to change this b here to a, both will change because they point to the same location in memory. b is referencing a, and a is in a specific location in memory. So if I were to just bring up a drawing application here, then let's say this is our RAM. Big chunky boy. Right? And we say a is equal to 10. The location of a, we can say, is right here. So this is where a is housed. It's where its location in the memory is. So when we say b is equal to 10, then, or let's say b is equal to a here. So when we say b is equal to a, b goes to this location in the memory address. But b copies the value, so copies this right here and puts it here. So now b is also 10, so just copy the value that's in here. But when we say ampersand b is equal to a, we are saying this b here, it goes right there. A and b are the same thing now. However, b actually references a. So b isn't a, but it does point to the same location in memory as a. So you could see it as being the same as a. And references can be very powerful. And I'm going to show you a few basic examples. However, first I just want to show you something. So when we do this again, when we say this, and we print out the locations in the memory of these by just using an asterisk, or I mean an ampersand, then here you can see they're in two different locations in the memory. However, if we were to say ampersand b is equal to a, then b is referencing a, and they'll be in the same location as I said. But take note, this b here is not the same as this a here. This here will make b contain a pointer, so we need to do this. So now B here contains the pointer location for A, whilst this here makes B reference A. Very similar, but quite different. Let's do a little bit of practice. Let's create a function. Void change. Change is a function that will change a variable for us. If we say int v, and here we can say v is equal to 10, and now that's change. If we go here, we say a is equal to 12, we see out a, and then we say change a, and then see out a, we expect that a would not change. Perfect. So a did not change. And that is because this right here, that's a new variable. We're generating a new variable, just copying the value that's stored inside of a. However, if we were to add an ampersand here, a will now be referenced when we take in a here. So now when we run this, a will be changed to 10. So this value a here will be manually taken and it will be changed. This is very powerful and in a lot of cases very useful. In languages such as JavaScript, this does not exist, but sometimes you do wish it does because it could make life a lot easier being able to reference a variable instead of having to change that variable with a return statement as an example. You can also do references with pointers. So instead of putting an and there, we could put an asterisk there. However, this will just need a little bit of extra effort by us needing to go ampersand a here, because we want to point in the location here. And of course here we want to dereference this v and put that value there. So if you wanted to do it with pointers, it's 100% possible because they're very similar. By using an ampersand, it's basically just sugarcoating having to do a bunch of effort to get this value and store it somewhere else. So now if we go here, we get 10, or we get 12 and 10 again. We will be diving deeper into this in the future because this is a very powerful topic in C++. It's a concept that if you get it right, you can make a lot of powerful applications with it as well. And that's that. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next C++ tutorial.